Okay, a lot to cover in this video, even though the notes for it were only a page long. So I forgot these topics from chapter 1. The topics of anatomy can be broken down into gross or macroscopic, which means it can be seen without a microscope, and regional, which is studied area by area, and systemic, which is what we are doing with our A&P classes, which is system by system, and then surface, which means external form in relation to deeper structures such as X-ray and anatomic imaging. Okay, moving on to chapter 2. We have basic chemistry. This was very complex for me in my little mind. So I basically just broke it down from what I had in the notes. So an element is the simplest form of matter. There are 3 common elements in the body, and those are sodium, or Na, K is potassium, and H, hydrogen. 96% of body weight results from oxygen, carbon, hydrogen, and nitrogen. Did not know that before either. An atom is the smallest part of an element that has chemical characteristics of that element. A neutron has no charge, and a proton has charge. Electrons have negative charge, and the sign for electron is E negative. So, in further notes, that is what it means. An ionic bond is when an electron is lost or shared. If the ion is dissolved in water, it is an electrolyte. A covalent bond is when an electron is shared. H2O is 1 atom of oxygen and 2 atoms of hydrogen. A molecule is 2 atoms combined. Can be the same type or different types of atoms. And then a catalyst is a substance that increases chemical reaction without being depleted. An enzyme is a protein catalyst. And inorganic chemistry is the study of substances that don't contain carbon, i.e. any mixture of liquid, gas, or solid. A solution is a solute that is dissolved in a solvent. And an acid is a molecule or compound that releases hydrogen. A base is a molecule or compound that accepts hydrogen. And then we go on to pH levels. A pH less than 7 is acidic. Greater than 7 is basic or alkaline. pH at 7 is neutral. Side note is normal blood pH is 7.35 through 7.45. Then organic chemistry is the study of carbon-containing substances. There are 3 major groups of carbohydrates needed. You can find those on figures 214 and 215, and you can start reading about it on page 40 of the textbook. The 3 major groups of carbohydrates are monosaccharide, which is simple sugar, galactose, fructose. The second is disaccharide, which is 2 simple sugars, sucrose or table sugar. 3 is polysaccharide, and that is many sugars, glycogen, starch, cellulose, that sort of thing. Then there are 4 major groups for living things. There are carbohydrates, and yes, I was too lazy to write them all out, so I said 3 groups talked about. 2 is lipids, fats, triglycerides, which equal 95% of lipids in humans. And then it said glycerol plus fatty acids. Not exactly sure what they meant by that. You can read about that on figure 217 of the textbook. And then 3 is proteins, which is carbon, hydrogen, oxygen, and a little nitrogen, and sometimes sulfur. Then you have nucleic acid, which is carbon, hydrogen, oxygen, nitrogen, and what was P? I forgot. I didn't even look at that. Anyway, that makes deoxyribon. No, okay, I'm not even going to try to say that. Anyway, acid or DNA, and ribonucleic acid, which is RNA, i.e. messenger RNA, etc. So there is the notes for chapter 1 and 2.